Hi guys, welcome to Piece of Code and welcome to this video. So in this video we're going to learn about a new design pattern which is known as the builder design pattern or the builder pattern. And this is also a type of a creational design pattern because here you build objects. Now what do you mean by building objects? You can compare it to some real life scenario where you build something. For example, building a house or building a car, etc. Now in each of the scenarios, whether you are building a house or building a car, there are several steps involved in it, right? Because you do not go and build a house at one shot. There are certain steps in building a house. For example, you first build the foundation, then you put the pillars, then you build the roof, columns, door, windows, so many steps, right? So if you consider this house as an object, so there are several steps to building a house, and each step will move towards the completion of the house. Now obviously if you have built the foundation and the pillars, still the house is not constructed. It means that the house object is not ready. It's still in some, I would say, intermediary stage. Once all of the steps are completed, you will get a final house, which will be your final object. I hope that is making sense. Now, if you just take that real life scenario and put it in this programming paradigm, you will get a builder design pattern where you can build complex objects, and you delegate that building of the complex objects to something known as a builder. Now you may argue with me that you know what, if I have a class, for example house, I have all the members and everything, I can directly call the setter and getter methods or use the constructor to construct the object. Yes, that is true, but here the question is not whether or not you can create an object or not. Create an object is as simple as calling the new keyword, right? Here is how do you efficiently build a complex objects, because when we talk about a complex object, right, there might be some optional fields, there might be some required fields, some validations, and the final product that you receive might vary from one to another. Let's take an example over here. So if you are building a house over here, right, this is house 1, this is house 2, and this is house 3. Now all of this house 1 have several steps. For example, the house needs a foundation, doors, roof, paint, woodwork, etc, etc. Now this guy who has constructed house 1 has taken all of the things, he has completed all of the steps, and he has got the final house object or the final house. This guy who is constructing house number 2 said, I don't need the paint, I don't need the woodworks, I just need a basic house. So he just did the foundation, the doors, the roof, and some windows. That's it. But still he got the house object at the end, even though he didn't do the painting and the woodwork, because it is not mandatory. House 3 did some more, he left some more things. I mean, he just did the foundation and did the pillars and the roof and said, okay, my house is complete, I don't need much more, something like that. So you see, each of the scenarios, the requirement varies from one scenario to another scenario. The requirement varies. Some are mandatory fields, some are required fields. By fields, I'm referring to in the actual programming paradigm, where you have a class and then you have your class member variables or fields, you can say. So here you can see there are three variations of the same type of object, right? And these three vary in different vary in object construction. One is different from the other, right? I hope I'm making sense. Why do you need a builder in this case? So what you do is just delegate your construction of your object to a builder, and at the end you will get a final object. I hope that is making sense. Now let us talk about what can go wrong if you do not use a builder. I mean, as I told you, you have your setter and getters, you have your constructors and everything, right? What can go wrong? Let's consider you have a house class house, right? And you have string foundation, string pillars or columns, string roof, string doors, string windows, etc., etc. You have all these things. You also have string paint, for example. Now if you do not have a builder and there are certain properties of this house which are not mandatory or optional, you can say. For example, this paint is not mandatory, windows are not mandatory, and doors are not mandatory. Let's say, I mean, it is not the thing for an ideal house, but we are just discussing about a hypothetical situation where you do not have those windows and whatever. You are very trustworthy and you say nobody will rob me, and I like the wind a little bit more. Okay, whatever. So what will be the possible solutions to this? Because you cannot create one single constructor house, right, and you accept all the parameters and you assign over here. That is not a viable solution, because a lot of them are, like 3 of them are optional, so you cannot accept all the parameters and assign it to them. One thing you can do is you may expect some parameters which are not mandatory, like doors, windows and paint. You can accept null values for that. You can keep a null check over here and assign null at the end, which doesn't make sense. It's not a good programming thing to do in the constructor. So this is not a viable solution. I'm not going to create a all args constructor, right, to handle this scenario. Second thing what I can do is I can create a constructor chain, or a chaining of constructors I can use. I can have multiple constructors accepting different types of parameters, and some of them will accept optional parameters and some of them won't. So I'll have one constructor over here, house. It will accept foundation, pillars, roof. Okay, this is the basic constructor where it will accept only the mandatory fields of your class, and I'll just assign it to them over here. And I'll have another constructor over here if someone wants to the paint of the house. If someone wants the doors of the house. So I'll have all this required things over here. Along with that, I'll have doors over here. So from here, what I can do, I can call the constructor with a basic constructor over here with these values, and then just assign this dot doors to the doors that I receive over here. Simple thing, simple constructor chaining concept. Similarly, I can have another constructor. I'll accept all the required things. In this case, someone just wants the windows, and the same thing I will do over here that I did just above. for the doors. Similarly, I'll have another constructor for the paint. Then I'll have a little bit of variation of constructors which will accept doors and windows, windows and paint, and then another constructor will be a all arcs constructor which will accept all of these properties. Right? You see, just by talking about this thing, makes us a little bit more worried, because it is becoming complicated, and we do not want this. We do not want to handle all the scenarios in our class, which we want to just construct. Just for constructing the object, we cannot keep all this logic inside the same class. Another thing that you can ask me is that having the concept of setters and getters. Yes, you can have a lot of setters and getters in the same class, and you can have a lot of validations and your logic, and based on that you can do it. But see, the primary objective of setters and getters is just to work. It's about encapsulation, right? Because why did the concept of getters and setters even came into the picture? Because you want to keep private variables, and your getters and setters will be public, so that you will be able to easily access and manipulate your variables over here. But here that is not the question. Our question is to constructing a complex object, right? In this case, a house, based on certain validations, logics, and certain checks. You do not want to overly use your setters and getters in this case. You don't want to use that, or you don't want to directly use your setters and getters to work on your object, right? That is why we have design patterns for that. If that was the case, just to construct an object using setters and getters, you would not need any design patterns. You will directly go and do whatever you want. But here our job is to make or write efficient code, not to write spaghetti code. I hope that is making sense. So yeah, these are the limitations due to which we should use builder pattern. And obviously I'm not stopping you to use all these concepts, because these are concepts, right, of object oriented programming. Because these were getting complicated, we are moving towards design patterns. Okay, I hope that is making sense, and we did a lot of discussion on how to construct an object and everything. But let us talk about how to work with this builder pattern. So you have your house object over here. What you are going to do is you're going to delegate the construction of the house to a house builder or a contractor or whatever, right? In a general scenario, you delegate it to a contractor or a builder, someone like that, right? You can yourself go and build the house, but do you do that? No, right? You delegate it to a respective builder or an agency or something like that. So what will happen in this house builder is that it will have a reference, or it will have has a relationship with the house class, right? And because why has a relationship? Because obviously it needs a house to construct a house, right? It needs to have a reference to the house to construct that particular house. Now using this house builder, we will start constructing the house. So basically we will first build the foundation. So build foundation, then build pillars, then build doors and something that. At the end we will call the dot build method. Obviously you will only create this method, and at the end you will just call the dot build method. It will return you a concrete house object, and you can then use the house whatever you want. Now why did I say that at the end it will return a concrete house object? What about all these intermediate steps? Are we not getting a house objects in this intermediate steps? For example, after constructing the foundation, are we getting a house object? After constructing the pillar, are we getting a house object? No. In this intermediary steps, we are getting the same house builder instance only. See, very simple logic now. Until your house is built, can you live in the house or can you utilize the house? No, right? It is still in building state, right? Just compare it to a real life scenario. Similarly, in every intermediate step that you use, you will not get the concrete house object in each intermediary step. Instead of that, you will get the same house builder object on which you can perform further things. I mean, whenever you are going to see the example, the coding example, you will get a little bit more picture on it. But for now, just understand that at the end, when you call the build method, that is the time when you will get the house object. Now you may ask a question, I do not need some mandatory fields. Can I call the build object before, after just doing the foundation? Yes, if you call the build object, build method over here, you will get the house object. But while you are doing the intermediary steps, you will not get the concrete house object. I hope that is making sense. Okay, so lot of discussions we did, lot of theory. I know it might get boring, so we'll just go over to our editor and start doing some coding right now. So let's create a new package over here, and I'm gonna name this package as builder pattern, right? Now over here I'm gonna create a new Java class called house, and so here we're gonna keep all of our things that we need. For example, private string, what we need, the foundation, private string columns or pillars, private string roof, private string door, private string windows, and let's keep it to a minimum, private string wood, and then private string paint, right? I hope that is making sense. Okay, so let us generate some getters and setters over here. So just gonna do an alt insert, and we're gonna just generate getter and setter for all of these things, right? So that it will make our lives a little bit easier. This is the concept of encapsulation. Okay, so now we're gonna just create another class. It will be very simple, and we're gonna name it as house builder, right? Now here, first of all, we need an instance of the house because it has a relationship. So we'll have the instance of the house, which is private house, right? That's it. Now we will have certain methods over here. In general, we will have static methods, which will be our intermediary steps, which will return back the instance of house builder, and then we can do more intermediary steps, and at the end we will need a build method to build the house or complete the house object. So let us do that. So first of all, I need a public house builder, obviously the return type, I would say the foundation, right? I'm gonna accept a string foundation, right? Okay, now I just forgot that thing. Along with the house, we also need these properties, because we need to set those properties in the builder as well. Sorry, I just zoned out a little bit. So I'm going to just copy this from here to here. So I'm just gonna say this dot foundation equals to foundation, right? And then we're gonna return this, because this means we are returning back the instance of the house builder, right? Now what I'm going to do is I'm just going to copy this method a few times, and because we have to do the same logic over and over again. So for foundation, for so we have how many? 1 2 3 4 5 6 7. So for 7 times I have to do 3 4 5 6 and 7. And we have foundation, then we have pillars, string pillars, and pillars and pillars. Then we have roof and door. So I'm just gonna say door, just gonna change it over here, then windows and wood. So we have the roof. Okay, we have also have the roof. Windows, wood and paint. Windows, why didn't I do this earlier? Windows, wood and paint. Okay, now at the end we need a build method, right, which will finally construct the house objects and return back the house object. Okay, so we'll have a public. Okay, we will just make this static. Okay, it's a this is a static thing. Okay, we'll just make this, we'll just keep it like that only, we'll not make any other, make it not complicated. At the end we'll need a public house build, right? Okay, now in this method you can write some validation logic. For example, if roof equals to null, or not roof, yeah, roof is a mandatory thing, foundation equals to null, or maybe the pillars equals to null. You can just for now let's keep a message over here saying that the mandatory things to construct a house are not there, something like that. And then we just gonna return null, or if you want you can throw an exception as well, because returning null doesn't actually solve the problem. In this case you basically do not want to construct the house, right? The house is not complete, so you just throw an exception or something, but in this case I'm just returning null, so to not make this overly complicated. So over here what we need to do right now is pretty simple. You just want to do this, which is you construct a new, so you already have an instance of the house over here, so you're just gonna do house equals to new house, and house dot set foundation. You can just say this dot foundation. I'm gonna copy this a couple of more times. 2 3 4 5 6 7. Similarly you have set pillars, this dot pillars, right, and then you have set roof, which is this dot roof, then set door, this dot door, set paint, this dot paint, set windows, this dot windows, and at the end we have set wood, this dot wood. Yeah, and then you just do is you just return the house object. So yeah, that's how it will work. Then you can have a client over here which will use the builder. So I'm just gonna create a client. Sorry, the spelling is wrong, I don't care about it. So house equals to new house builder, right, dot foundation just something I'm just putting over here, dot door, no, not door, we'll just have a very simple house, roof, and then dot pillars, steel, something like that, right, and then dot build. And in this house I'm just gonna create a toString method. We can just alt plus insert, we're gonna insert toString, and so that we can see what have we constructed. So in the client I constructed a house, and if I use the sout over here and just display the house, we will see what house we have constructed. So I'm just gonna run this. So you can see that foundation is cement, pillars equals to steel, roof, door, roof is there, door null, because these are not mandatory fields, right? So if you want to add something which is not mandatory, you can add it. For example, dot paint, maybe red, right, and then you just run the code. So you can see that paint is red. So if you do not provide a mandatory field, and if I just run the code, mandatory things to construct a house are not there, and the object it is returning as null. But as I told, you should throw an exception in this case. That is the correct programming logic. Now you may ask me, okay, this example is all nice and fancy. Do we have any actual implementation of the builder pattern, and do we use it on a regular basis? I would say yes, it is there. And that class, actually there are a lot of classes, but the very I would say mostly used class, I would say, in a normal day-to-day programming is the string builder or string buffer. Both are the same things. String builder. Okay, let's see the classes. Okay, we have the classes. Okay, not big decimal. Why did it open? So if I go inside this string builder, so you can see that there's a final class over here, and then we have a couple of methods over here. You see, like the append method, it returns append string dot value of object, but if you see, the return value is the string builder itself. Here another append method. A lot of methods are there. Delete, character, at, insert, all of these are returning a value of string builder. and then after, in the end, when you want to convert it to a string, there is a toString method over here. So you can just call the toString method to convert the string builder to a string. I know you are using this a lot in the day-to-day life, but this is how it works. This is also an example of the builder pattern, and you can see there are a lot of operations on this builder pattern, and the constructing a string is a complicated thing. I mean complex because you can have multiple variations of the string and whatnot, right? So in this case it is better to use a builder pattern because it will provide you the extensibility and the I would say the reusability, and it is very, I would say, what, flexible. I would say that's the word I was searching for. I don't know, it didn't come to my mind. Okay, I hope that is making sense. Similar class is a string buffer. The only difference between both is this thread safety. One is thread safe and then the other one is not. Right, that's why if you see in string buffer, you see the synchronized keyword. This is thread safe, but generally string buffer is not that much used because of performance issues, because once you make this a thread safe, I mean only one thread will be able to access it at a time. This just becomes a little bit more on the sense of performance. If you're working on a single thread, then that is fine, but if there are multiple threads, then yeah, it's better to use the string builder. I don't want to go into that concept that much, the multi-threading concept. If you want a video on that, you can just ask in the comments. I may make it in the future. Okay, so that was all about the builder design pattern, guys, and I hope you enjoyed the lecture. I'm going to make some more design patterns which are important, and till then, have a nice day, take care, and bye bye.